Welcome to another video on linear programming in Python. In this video, we will see how to perform mixed integer programming in Python. So, what is mixed integer programming? In short, known as MIP. Well, it's a problem where we have some conditions on the decision variables x, y. So, the decision variables have to be integers. They cannot take fractions. So, your decision variables cannot take values like 2.5 or 3.6. They have to be integers. So, that is one extra constraint that we add to the linear programming problem, and for that we use mixed integer programming. Here is this example. We will take this example to see actually how we can actually do that. So, it is a maximization problem. The objective function is x plus 8y, and we want to maximize this with respect to few constraints. So, the first constraint is x plus 6y must be less than equal to 15, and the second one is x should be less than equal to 4. So, these are the two constraints we have, and let us try to see how we can maximize the objective function x plus 8y given these two constraints. In this video, we will actually install the OR tools from Google. So, this is a tool created by Google for optimization purposes. So, we will not use the previous ones, right. In the previous video, we use some tools from scipy.optimize. We will not use these tools. We will rather use a tool from Google. It is called OR tools. You can install it first. So, this is how you install. So, this is not automatically there in Jupyter. So, you have to use pip install. This is how you install in Jupyter. And from there we will have to import what is known as pyrap LP. Okay. So, or.tool.linear_solver, we import this wrapper pyrap LP. Remember one thing, that the underlying solver is external. It is not something Google has developed. It is using some open source solver. So, one that is used is SCIP, but you can also use other solvers, and you can also write your own solver and call that. But the idea is that you can use any solver using this wrapper and solver in mixed integer programming problem. Okay. So, here we call this solver, as I mentioned, this SCIP is an open source solver that Google's wrapper is using. So, first we define the decision variables. So, in this case we have two decision variables. You could have more than two also, x1 y, and the syntax is very simple. We use solver dot int var, and we provide what is the minimum value. Here the minimum value should be 0 in this case, because we want them to be positive, but you can also define anything. You can also define like, okay, negative infinity to whatever value you can take. Okay. It is very similar to how we use the optimize function module from the scipy package. Very similar syntax, but remember this, in this case we can use both maximization and minimization, whereas in scipy it is always the minimization. So, we have to convert a maximization problem to a minimization problem there, right. So, if I have not gone through these two videos, I highly recommend you to go to the first two videos where I have used scipy package for optimization, and then we will define the constraints. The two constraints, x plus 6y should be less than 15 and x should be less than equal to 4. Syntax is very simple, solver dot add, and then in bracket you basically define your constraint. It's very easy, right. Whereas in SciPy the syntax is a bit more complex, I would say, right? You have to provide the coefficients in a matrix form, right? If I've gone through the other two videos, the first two videos, then I'm sure you know actually what I'm talking here. So here the syntax is a bit easier to understand, also to okay. The second constraint, x is less than equal to 4, same syntax. Let's run this. Okay, I think we have not run this yet. After that, you define the objective function. So in this case, it is x plus 8y. Syntax is solver.maximize, and if it is minimization, just write solver.minimize. It's the maximization, so we'll write maximize. We run this, then we will solve it. Okay, and then we store it in status, and then we will use some sort of syntax to print the result. So this it's very easy again. If the status is optimal, that means there is a solution, then it will provide you the solution. Otherwise, what we print is that the problem does not have an optimal solution. So only if there is an optimal solution we get results, otherwise we won't. Right. So here we go. So the value of x is 3 and the value of y is 2, and both are integers, right? You will never get something like 3.5 as an answer or as a value to your decision variable, or 4.6, always integers, because this is mixed integer program. All right. What would have been the answer if you had to use the linear programming, the more normal linear programming, right? What values would have maximized this objective function? What we will do is that we will just change the solver. Instead of using a mixed integer solver, we will use more of a linear programming, a normal linear programming solver, which can also have non-integers as decision variable. So here we use this GLOP. Okay, so this is not mixed integer linear programming. This is the simple linear programming. So it can have non-integer values for the decision variable. So we run it again, and then we will okay, so we'll solve this, taking some time. Whew, okay, there is some issue. I have to rerun some of the things, but that should be fine. We solve this, and let's print the results, and here you see the solutions for this problem is x equal to 0, y equal to 2.5. So 2.5 is not an integer, right? So for a very simple, if you use simple linear programming problem for this objective function, the solutions are 0 and 2.5, whereas if you use a mixed integer programming problem, you get values as x equal to 3, y equal to 2. So that's how we use a mixed integer programming to solve a linear programming problem.